Hello, everyone. My name is Jeff Kiske. I'm co-founder and CEO of EngineML. And today, we will train an AI agent to detect cats in just 5 minutes. We will accomplish this feat in only 5 minutes by using EngineML to dynamically launch 64 GPUs that will simultaneously learn from 8,000 images of cats. I'm joined on my stage with my co-founder, Ben Perez, who just launched a 64 GPU training job with a simple git push. Behind the scenes, EngineML is dynamically provisioning 64 GPUs, optimizing networking, and dynamically prefetching your data. While our model is launching, I'll explain why this wasn't possible to do in 5 minutes until recently. Before cloud-based GPUs were available to the general public, only well-resourced corporations and universities had access to this scale of compute. In 2012, Jeff Dean and Andrew Ng of Google Brain networked 16,000 CPUs and made headlines with a model that was able to distinguish cats. A single iteration of this model took them 3 days. Around the same time, Alex Krzyzewski figured out how to use GPUs instead of CPUs, and he got first place in the ImageNet competition. A single iteration of his model took 6 days. Accuracy continued to increase, but so did training time. This culminated in 2015 when Facebook got first place in the ImageNet competition, but a single iteration of their model took 10 days. Since each experiment took so many days, each of these results required hundreds of days of experimentation to achieve. In 2017, Facebook was able to cut their training time down from 10 days to just 1 hour. In a paper unambiguously titled Training ImageNet in 1 hour, Facebook showed that with some minor tweaks, they could achieve 200 times speedup in their training speed by distributing the workload across hundreds of GPUs. However, this technology is still not available to the general public and requires oftentimes dedicated teams to get it set up. With EngineML, all companies can unlock this sort of speedup. At the beginning of the presentation, Ben launched an object detection model that was at the top of the MS COCO leaderboard for some time. Unlike ImageNet, MS COCO is an object detection challenge, which means that instead of for the model only being able to identify whether an image contains an object like a dog or a cat, it also must localize where that object is in the image. These models are significantly more challenging to train and often take much longer. Since we only have a short time on stage, Ben's going to train this model in 5 minutes using 64 dynamically provisioned GPUs across 8 cloud servers. And in homage to the Google Brain team, we're going to use this model to detect cats. Although this model is relatively simple, it would still take 6 hours to train on a local desktop with 1 GPU. Most production models are much more complex, and since engineers are often stuck training on local machines with 1 to 4 GPUs, models often take 3 to 5 days to converge. EngineML can shrink that time by 100x. This is a paradigm shift in how machine learning teams work. It means that in a 2-week sprint, instead of only being able to do 2 to 4 experiments, engineers can now do 20 to 40. This allows them to iterate more quickly, try out new ideas, and get their product out even faster. With faster engineering cycles, experiment management software becomes much more important. This is the EngineML jobs dashboard. It allows you to view and actively manage your workflows in one place. From this dashboard, you can track the progress and view stats of your experiments, and it's a really nice view. Let's dive into the cat detector that Ben launched at the beginning of the show. This is the metrics dashboard. Here we can see that this job is actually running on 64 GPUs across 8 hosts. The top graph is GPU utilization. This helps your engineers find bottlenecks in their code and can eventually make training even faster. Up next is the logs view. Logs from your model are streamed to this page, and this provides invaluable debugging information for your engineers. We can see that the TensorFlow graph has been built and that this model is starting to make progress. Now that we've been training our cat detector for around 4 minutes, let's take a look at the results. In under 5 minutes, our model has iterated over those 8,000 cat images 60 times. Here we can see our TensorBoard scalars. Up here we have average precision, loss, and learning rate. These metrics are also mirrored over to the EngineML dashboard we showed before. When we click on the Images tab, we can see how the model's done. The model learns over time and continuously improves. The detector is only able to make such rapid progress due to the scale of this computation. Finally, these GPUs will automatically shut down once the experiment's complete. At $200 an hour for 64 cloud GPUs, this is critically important. To recap, we used EngineML to train a model that would have taken 6 hours in just 5 minutes. Whatever the core focus of your business is, it's likely not building distributed training infrastructure. EngineML allows you to realize the same level of performance as Google and Facebook without the massive time and infrastructure commitments. Thank you, and if you're interested in accelerating with us, feel free to reach out at engineml.com.